Hello everyone and welcome to the next episode. In this episode I'm going to show you how we can calculate the density in code. So we will write the actual calculation of the formula and yeah, that's everything for this episode. So let's jump right into the code then. So let's do the density calculation. This is actually pretty simple. If you have the paper with you, if not, it's totally fine. I will show you the equation here anyways. But if you have the paper present, the particle-based fluid simulation for interactive applications paper, link is in the video description. On page 2 and equation 3, here we can see how the density is calculated. It is just a sum with the mass and the kernel, the W with the R minus Rj and the H. It is quite simple. If you're doing it for the first time, you might have questions, but I will show you it is really simple. So let's do a method called compute density, right? And here we need to loop through every particle in our simulation because we want to calculate the density of every particle. So let's do the loop stuff. We loop through everyone, and then I will get the particle we want to calculate the density for. Just really simple stuff here. Then I will set the density for 0. One important note here is that later we will add a self density. So for example, if we do it like I have it right now and our particle is is somewhere in the simulation domain where there is no neighbor, the density of this particle will be 0, of course. And at some point, we will have a division by 0 error because we need to divide by the density at the integration step. So this is a huge problem, and I had a lot of problem with this trap, and yeah, don't do that. We will change this later. Really important. Then we have, of course, another loop. We will replace this loop later with our neighbor search, so we don't do like currently we will loop for every other particle in our simulation, right? And this is not necessary because a lot of particles won't be in our radius or in our search radius. But for now, we will do that like this because it is the easiest way to debug. Like, for example, if you're doing a neighbor search and at the end, your neighbor search has an error in the mapping, for example, and yeah, this will like mess up everything with the calculation of like densities, pressures, the surface tension, and a lot of stuff. So it is really good to start with just 2 loops, and it's the easiest. You can debug it. Do this first if you do it the first time, and yeah, it will be way easier. Okay, so with our second loop, we will get the neighboring particle. This is also pretty easy. We just say this.particles, and then with our other index, then we have to get the distance between those 2 particles. And for this, I will just create a direction vector. And for this, I need to subtract the position of our particle with the position of our neighbor particle. And then I have a direction vector, and from that direction vector I can get the distance, which is just rij.length. Then I have the length of that vector, or the distance from my neighbor, and yeah, then I can calculate the density. And this is done by using the formula. This is just the mj, right? We need to use the mass of our neighboring particle, so pj.mass, and then times kernel.poly, which is called the kernel we implemented last time, with the distance, and then the interaction radius. Yeah. I already declared the interaction radius. This is also the parameter h, or I think L at some papers. Yeah, this is just the radius where we search for, and I set this radius already on the top here for of 20. 25 is my usually go-to if I do those simulations on the HTML canvas. A small note, I made a mistake in the last episode. I think currently we can't call the kernel a method because first we need to change this letter here to a upper letter, and then I have to add static in front of the poly, and then we can call this method, or it will not throw any error, but we still need to call it in our update method. And when we now save and start the simulation, or just start the index.html file, we should see a square of particles. And when you go to the dev tools into the console, you should see, yeah, of course you won't see anything because we of course need to print the density of the particles. So we can do that too, of course. So density of particle I is pi.density. So now if we refresh, and I think I made a small error. Yep, I have to say log and save. Don't forget to save that stuff. And then if you go back to the console, you will see a lot of densities printed in there of every particle, and our density is around 0.004 to 0.005. And this is quite right for this one. And yeah, this is everything already for this episode. In the next episode, we will calculate, or I will go through over pressure. We may gonna calculate the pressure already. I'm not sure right now. But yeah, we will go through some pressure equations on how to transform the density into a pressure number. Yeah, and that's it. Thank you very much for watching, and I hope to see you in the next one. Have a nice day, and bye-bye.